Start with a bit of an introduction about yourself and how you got to where you are.
Hello, my name's Rob. I'm the Chief Technology Officer of a company called MakerX, and we build digital products end to end for startups, corporates, and venture builders. And we've been building on Algorand since sort of, I don't know, the last half of the last calendar year, I guess you could say. And as you mentioned, one of our projects is the Data History Museum, and that was in fact the first one that we did. And to understand why we did that, I guess maybe briefly describing the business model of our company. There's two types of work that we do. We do client work, so we, you know, a client will come to us and we'll go and understand the business problem that they're trying to solve. And mainly we focus on building out the digital products that power ventures, so new businesses, so helping them to successfully build a new business by delivering on the digital product that is behind it. And, we do all of that, right? But the other part of our business is that we actually build our own ventures. So when we've got an interesting idea, we'll go and essentially build it for ourselves and turn it into a business and get funding and whatever else it is that we need to do. And the first one that we built was the Data History Museum, and essentially we're kind of, I don't know, had this realization really, and it spawns from the idea of thinking about a physical historical artifact sitting in a museum. And if you look at that artifact and you think to yourself, well, why is that? What makes it a historic artifact? There's two intrinsic properties that you can model. So one of them is causality, which is the idea that I can draw a causal link from, my cat's going to appear in this, a causal link from that object in the current moment in time all the way back to the point in history where either it was created or touched that made it historic. And you can prove that it was there at that point in time through carbon dating. And then the second concept, the intrinsic property, is originality, which is the idea that it's the historic artifact, not the copy in the gift shop that you can buy for $10. Now, the realization that we had that spawned the idea of doing the Data History Museum was that for the first time ever, a public blockchain gives you the ability to model those two intrinsic properties in a digital form in a way that you haven't been able to before. And so why is that? Well, if you look at causality, the mint time of a digital token in the blockchain is a fact that is immutable and publicly inspectable, which becomes the equivalent of carbon dating, by the way. And our hypothesis is that if you create a representation of a historic event close enough to the point in time that that historic event happens, as a direct and automatic reaction to that event happening, and then you can prove that by looking at the mint time on the blockchain, that we have preserved this causal link, as we call it, the intrinsic property of causality. And then originality is really easy. It directly translates to non-fungibility, the fact that there's one and that it's unique and that you can prove it's the one. And so essentially what we've built with the Data History Museum is something that enables us to curate and collate historic events that are either terrestrial or cosmic or human in nature as a direct and automatic representation of them into what we call a verifiably authentic digital historical artifact, represented as an NFT on the Algorand blockchain. And so since I think it's the 25th of January this year, we've minted every magnitude 5 earthquake that's happened in the world. Earthquakes are the first historic event that we chose, namely because they're interesting, they're something most people understand, and they're available publicly thanks to the United States Geological Survey, the USGS. So they're easy to implement, I guess, as the first kind of thing. at the moment, we're in the middle of building, and actually, since I think it was last week, yeah, at the end of last week,
Hmm.
we've started minting solar flares as
Yeah.
well. And we're in the middle of building out the pretty hardcore implementation to actually get a video of the solar flare
Hmm.
as the satellite in space took it, which is kind of awesome.
Yeah.
And yeah, so that's what we've built with the Data History Museum.
Cool.
So it's a really cool project. I mean, we're all like, science nuts, right? We love this stuff. We
Yeah.
think it's really fascinating.
Yeah. Yeah, no, when I first heard about the project, I thought of it in kind of a different view, right? So you're talking about kind of the creation of artifacts at points in time. I was looking more at it, we have historical artifacts, but over time they get damaged or lost, or we can no longer actually preserve this information, right?
Yeah, yeah,
Or
yep.
even generally historically, whenever there's large scale conflict, there's a lot of knowledge that becomes lost because the invading party or whoever will end up burning books, or the Library of Alexandria is a quite famous example where literally hundreds of
Mm.
years of knowledge was lost in a big fire with no way of preserving it. But now with the blockchain, you can effectively preserve anything on there, whether
Yeah,
that's
yeah, exactly. In a permanent record. And look, taking that even a step further, you think about the fact that our society is increasingly digital. There's heaps of information, history, right? Historic
yep.
things being created that are actually digital only.
Hmm.
And we just don't have a record of them in the same way maybe that we did in the past. So
Yeah.
for sure, it's that combination of cool, these are verifiably authentic, there's a permanent record, and we're able to catch digital and non-digital, things, right?
Yeah.
Um, so yeah, and look, we've got a pretty ambitious vision for what we can do with this thing, into the future, and it's a multi-year journey, but part of our vision involves changing the way that science is funded globally. So there's some cool things we can kind of do with the concept, I guess, of what we've
Yeah.
created.
Yeah, no, because looking at the earthquakes, you're documenting earthquakes, which will a lot of them will for the most part go unnoticed because of where they happen. They happen in the middle of the ocean. They happen in places with generally low population density, so it doesn't really show up on the news unless you're actively looking for it. So it's kind of just more information for people to see. And, in terms of, I guess, funding science, for certain people, it may become, a sort of collectibles item, right? If someone's really interested, if they were somewhere when an earthquake happened, they might think to
Yeah,
themselves,
exactly.
hey, I want this NFT so I can be like, hey guys, I, survived.
I felt this earthquake. Yeah, exactly. And that's the fascinating thing is that one of the realizations we've had in doing this is that in some cases these historic events are actually hyper localized in their interest, if you will. Obviously, there'll be some that are, much more broadly interesting because there are news cycles everywhere. Maybe you think about something like the Tonga one that happened last year. Um, and look, that naturally raises some questions around, hey, some of these things are actually disasters and they have a really bad like impact. And so one of the things we were very deliberate to build into the project was the concept of using the funds towards science, but also using them towards disaster relief and the like, so that you know the, there's something that we can actually do for good with this beyond just we're
Yeah.
minting some NFTs and selling them. It's so much broader than that, to be honest.
Yeah, and I think this has a lot of implications for, I guess, science in general, right? So a lot of this information might not have been available, or records may only go back so long. So if we're documenting all of this information on a public blockchain record, someone in the next 50 years or 100 years may actually be able to conduct sort of like a meta study of this information, and
Mm,
actually draw trends that we're seeing, and whether that will help them identify tectonic plate movements or something else of the sorts. It's quite interesting because a lot of things such as air quality. Monitoring air quality is quite an important
Yeah.
thing. So if that's something that we can publicly store on a blockchain, so someone in a 50 or 100 or 1,000 years can come and say, oh hey, in the year 2022, the air quality was like this and it's changed since then.
Yeah.
And now we can actually understand the impact that we've had on our climate and our environment through this historical data, which would otherwise probably not have been preserved, right?
Quite possibly. Yeah. Exactly. Yeah.
Yeah. Um, yeah, no, I'm on the solar flare page of your website. Obviously, there's not much on there right now, but I think solar flares is one that's pretty cool. Um, a lot
I'm
cooler
excited to
than
see the
than
videos
earthquakes.
of them
Yeah. No, I think that'll be
because
awesome.
yeah, I've seen the early versions of it that our developers have been working on, and they look amazing. Like
Mm,
you can see the sun, you can see this thing pop out, and it's like,
yeah,
wow, it's so cool.
yeah. Um, Yeah, no, honestly, that's we've covered I think most of what the platform does. Is there anything else that you're working on in general that you might want to talk about as well?
Yeah, well, I mean, I guess the interesting thing is in building the Data History Museum, we had to build this highly sophisticated, highly automated asset minting system
Hmm.
because in order for us to protect the causal link, we have to mint an artifact, within a short period of time from when it's first detectable, right,
Hmm.
via API.
Yeah.
And so this thing has to be running 24/7 because otherwise we would miss a mint,
Yeah.
and it has to be without human interference.
Hmm.
Otherwise, these artifacts don't really meet our definition in our white paper of what a verifiably authentic digital historical artifact is. But more than that, the metadata that we get from the USGS actually mutates over time. So, for instance, when we first find out about an earthquake through the USGS, there'll be some data attached to it. And then, as their data processors run over that data, and as they get data from other monitoring stations that were maybe a bit further away, had a slightly different kind of set of data, what we find is that the magnitude of the earthquake and the geolocation and the depth under the crust, they all change very slightly by
Hmm.
like 0.01 and
Yeah.
really small numbers like that. But we obviously want the historical record to be up to date. So our sophisticated minting system not only does creates, but it also does updates of the metadata over time.
Right.
And what we realized is, in talking to a few different clients of ours, is that there's a general purpose, I don't know, problem or solution, depending on which angle you're coming at it from, in having this sort of digital asset minting where you take a third party data source or data
Hmm.
sources and you reflect that into a digital asset representation on a blockchain. And the reason why you might want to do that could vary, right? There are a number of architectural properties on a blockchain, like public inspectability and the associated transparency, the immutability, the fact that you can represent ownership, the fact that you can represent transfers, the fact that you can then program interactions against that ownership.
Hmm.
These are all really interesting architectural properties. The way I see it is they're building blocks that you could use to make, um, a solution, right?
Yeah.
Um, and so what we did is we basically took the core of the Data History Museum out. We generalized it so it was less sort of earthquake specific,
Hmm.
which is the interestingly the first user of this new platform was the Solar Flare Minting and
Okay.
the Data History Museum, and we've turned this into a multi-tenant platform that we call OnRamp.
Hmm.
Um, the reason why we call it OnRamp's amusing. I originally called it the Reactive Asset Minting Platform, which is obviously a little bit of a mouthful.
Yep.
And my colleagues like to stir me up, and so they suggested that we call it RAMP. However, I hate acronyms because I think they obscure communication. So I said, we're not calling it RAMP. But I thought about it and I said, but I'm happy to give it a marketing label and call it OnRamp
Mm-hmm.
because if you think about it, that kind of platform where um, you can very quickly and very easily take a third-party data source and reflect that, create, read, update, delete onto the blockchain without having to worry about all of the metadata standards and having a sophisticated platform that's constantly running
Mm-hmm.
and figures out is this item already on the blockchain or not, and do I need to do a create or an update, and
Yep.
then do I need to deal with IPFS depending on which metadata
Mm-hmm.
standard I'm using? There's basically 6 months of work
Yep.
that we put into building all of that, that we've now abstracted into something that's a simple API call that, any developer could interact with very easily without knowing anything about Algorand,
Mm-hmm.
and have this highly reliable, sophisticated minting happening. And so, because of that, we realized that this is actually a really great platform to help on ramp Web 2 quote unquote developers onto Algorand in this case, so that they can mint digital assets. And in fact, our main target for this is actually corporate and enterprise use cases. You can use it for smaller things as well, but if you're in a situation where you need to mint hundreds of thousands of assets and or make those assets dynamic,
Mm-hmm.
then having something like this would actually save you months of work, and you could get it into mainnet in days rather than months. So it's
Yep.
quite powerful to on-ramp developers. So
Mm-hmm.
hence why we call it on-ramp. Um, yeah, that's kind of one that we've been working with recently, and so we've changed the Data History Museum.
Mm-hmm.
Earthquake Minting now uses it. With the Solar Flare Minting uses it. And actually, last week we launched a little fun collaboration project with Al, who
Yep.
is basically one of the key blue chip NFT projects on Algorand. And what we did is it's this concept that we mutually came up with of what can you do with a dynamic NFT? And in particular, there's a new metadata standard called ARC-19 that we're using that's interestingly in the last couple of weeks getting a lot of prominence because as well as ours, there's a couple of other projects that have launched, like Mostly Friends, that are quite big that are using it. Um, and the concept we came up with was it'd be really cool if you had some NFTs that change based on the price of the algo in this case, and it generates different artwork depictions to react to that price, and then you kind of lay them all out in a dashboard essentially.
Mm-hmm.
And so we created, and I can share screen and
Yeah,
show
go for it.
this.
Yep.
Excellent. And so basically, what we have is um, these every single image you see here is actually a dynamic NFT.
Mm-hmm.
And so you've got this one here, which reacts based on the 24-hour price, and it has an animated GIF. That one either goes down, flat, or up.
Mm-hmm.
We've got this one here, which represents the fear and greed index, which is a general industry one from
Mm-hmm.
alternative.me, but obviously with the goanna artwork on it.
Yep.
We've got these ones here. It's quite a day to be showing this, by the way. We've got these ones here, which show the 1 hour price change, 24-hour price change, 7-day price change, and 30-day price
Mm-hmm.
change. And they either go from a green happy
Yep.
um, you know, one or the
Mm.
negative 12%
Yep.
in this case, pretty angry looking one. And then the piece de resistance is this one here, which is a multi-layered artwork
Mm-hmm.
where the background changes based on the 30-day price change. So again, it's quite negative at the moment. So there's this kind of dark
Yep.
demon-like thing going on in the background there. The vehicle, which in this case is holding a to the moon sign, but goes all the way up to a Lambo. If you're like, over plus 10%, the outfit, which you can see is kind of looking
Yep.
pretty scraggly here, and the expression based on the 1 hour change, which I think the 1 hour change was not too bad. It's like
Yeah.
0.21, so it's just like a neutral expression. But all of these images change every hour,
Mm-hmm.
based on reacting to the price. And so everything that you see on this page, like all of these percentages, these are all stored in the metadata of these NFTs. So there's no live lookup to, we're using CoinGecko in this case, on this page. This is all actually from those NFTs.
Mm-hmm.
So we've created this dashboard, and look, this is just a fun kind of, you know, like
Yeah.
experiment, like a thought experiment of like what can you do with a dynamic NFT. But it's also just amusing because of the funny artwork,
Yeah.
right?
Yeah.
It's a good example of the power of what we can do with the on-ramp platform, because in order for me to implement that, it only took me a few hours. Um, it's basically an API called a CoinGecko, um, looking up which image I want to use based
Yeah.
on what came back, and encoding that image and the new metadata traits into a very basic JSON payload that I send to the on-ramp platform, which then handles, oh, that thing already
Yeah.
exists. I'm going to update those properties on top of what's already there, and then it just gets updated. So, it's a very small use case, but it's a good illustration of the power of it. Because, if I didn't have on-ramp, it probably would have taken me maybe a couple of weeks or a week or something to implement it. In this case, it took me a few hours.
Yeah.
So yeah, and it's a nice little example of of what we can do with that.
Yeah. No,
The
it's
other, sorry, you
no,
go
no.
ahead.
Go for it. Go for it.
I was going to say, maybe a more concrete example of a corporate use case might be a ticketing example. Um, so, for instance, let's say I wanted to have a digital ticketing experience where you get left at the end of the event with, an NFT that you own, where that NFT has been updated based on the way that you interacted in that event. So it's kind of personalized to you. So you can imagine, let's say it's an existing ticketing like company, they've got an existing system, right? Like a database, maybe there's an API, whatever. Um, with something like OnRAM, what you could do is have some small amount of code that you do that reads all of the tickets as they get bought, create digital asset representations on Algorand, stores the asset ID that got associated with that ticket. Then you can have a simple DApp where someone goes to claim their ticket, where they log in with their existing account and then connect their Algorand wallet, and it lets them basically claim their NFT. And then what you could do is, if you had, maybe when you sign in, you scan into the event using your ticket, which if you, for instance, have a barcode or something on the image associated with the NFT, you could actually do with the NFT if you wanted to. Um, you don't have to if you don't want to. That's fine. And then it records that, and so there can be a little process running to like essentially subscribe to events from their existing ticketing system. Say, oh, someone's checked into this. I'm going to send something to OnRamp to say, hey, here's the asset. Change the trait of are they checked into this, and change the image to this because we've generated a new one. You unlock a special thing on the image when you check in, and then maybe there might be like some interactions that you can do at the event. Like if I go to a certain sponsor stall, I get a stamp from that sponsor, or if I pay to upgrade to the VIP area, then it gets upgraded to a VIP ticket. Whatever it is, you do things, and these can be easily emitted into the blockchain to change your corresponding NFT asset. So you can keep looking on your device at your wallet and see it kind of update as you
Yeah.
interact. Which, things like that are really easy to perform, I guess, if you've got this sort of platform that lets you do really small snippets of
Yeah.
code that you don't have to worry about the blockchain stuff. You're just integrating from a system to a generic JSON payload.
Yeah.
So yeah, it's a cool kind of example of the sort of thing you can do.
Yeah, no, that's a lot of cool stuff. I mean, I was gonna ask you about the ARC-19, but you've kind of gone into it quite a lot. It's really, I'm familiar with what ARC-19 does, but I'm not really sure of its capacity. But seeing, the type of things that it can do,
Sure.
it definitely opens up a lot of use cases. I think especially what you mentioned about, if you go to like a conference and you get stamps from different sponsors and so on, that is something which is really interesting. You can even, if there's like a sort of like a treasure hunt where you need to go around the
Yeah.
conference, find certain people, you get a stamp from each, and then also that way, because it's all on the blockchain, you can probably much more easily calculate, who was first, who was second, who was third, and so on. Yeah, no, I think ARC-19 and like mutable NFTs, or rather dynamic NFTs, have a lot of potential. Yeah, no, it'll be interesting to see how a lot of these projects actually take this a step forward.
Yeah, exactly. And look, I'm really interested personally in all of the real world applications of it, right? Like the ticketing applications may be a good one, but there'll be a bunch of others that we haven't even thought of. And I think the ability to easily reflect dynamic changes to the metadata, is only a good thing if you think about it, because it just unlocks a whole set of extra use cases that involve mutability that otherwise would be a bit harder, right?
Yeah.
There's some others we thought of too, like think of stuff like anytime you need to token, like where it's valuable to tokenize something.
Yeah.
So again, if we come back to all of the architectural properties of a blockchain, one of them was around being able to represent ownership and transfers. Yeah. So tokenization of assets, and they might be like corporate assets as an example. Maybe they're like illiquid corporate assets, but they're things that are actually of value. You could create tokenized representations of them and then allow people to trade them to add liquidity, right? Now, obviously, there's certain regulatory things that you need to go through if you're doing that, and that's fine. You should implement that. That's okay. But the fact is that you can implement all of that so much easier on a blockchain that has this transparency, immutability, and public inspectability. There's not this kind of like smoke and mirrors, some sort of corporate system sitting in a company that you have no visibility of that could be manipulated in secret ways. Like it's a lot more open, right, and easier to implement on a blockchain that's built for demonstrating ownership and transfer of value.
Yeah.
So again, cool. I've got a database of corporate assets. I can now tap into that and create them, right? So yeah, like there's a whole bunch of interesting use cases. To me, it just comes down to making sure that you're actually implementing something that has real world value,
Yeah.
and something that where the blockchain is actually adding value, not just tech for the sake of tech. So something that actually needs those architectural properties that a blockchain has. So the Data History Museum is a great example. We can't implement that not on a blockchain. We have to have that immutability and public inspectability so that we can have the causal link, right?
Yeah.
And we need that originality. So the fact that you can prove that a given artifact is the original artifact cryptographically, super useful for a historical record that, a permanent historic record.
Yeah, exactly. For people wanting to know more about you, or where can they find you, is what I'm asking.
Yeah. So me personally, easiest way is probably on Twitter. I'm at Rob D Moore, MOORE. Or our company MakerX is at MakerXAU. And then the website for our company is makerx.com.au. So they're probably good starting points anyway.
Yeah, cool. No, awesome. Yeah, I'll include those with the description of the video and stuff as well. Um, Rob, it's been an absolute pleasure speaking with you. Thank you so much for taking some time out of your day. I really appreciate it. I've learned a lot about what you guys are doing, and the kind of capacity that it has going forwards. So I'm definitely going to be keeping an eye out on these, especially for the solar flares coming out. I'm quite excited for that one. Yeah.
So yeah, thank you.